This video goes over how to solve equations with rational exponents. So I'm still trying to get x by itself. This time it involves getting the exponent on the x to be 1. So for this first one, I would square both sides, which is the opposite of 1/2, opposite of dividing by 2. And that means that I'm left with x equals 49. If I have a cube or a 3 underneath, I'm going to cube both sides. Okay, this gives me x to the exponent 1 on the left and minus 27 cubed on the right, which I could cube using my calculator. I know that it's going to give me a negative value. As I continue, here I've got x to the 3/2, so I've got a number in the numerator and the denominator. And so I'm going to raise my left-hand side to the inverse of the exponent that I have, and I'm going to do the same to the right-hand side. So on the left, I now have x to the exponent 1. On the right-hand side, I now have the cube root of 27, all squared. The cube root of 27 is 3, and 3 squared is 9. Moving on to the next one, I've got x to the 3/2. So I'm going to raise the left-hand side to the power of 5/3. I'm going to do the same thing to the right-hand side. This gives me x is equal to the cube root of minus 8 to the exponent 5. The cube root of minus 8, or negative 8, is minus 2. Minus 2 to the exponent 5 is minus 32. E, F, and G look a little bit different. We're still trying to get x by itself, except now we have some other operations involved than just the rational exponent. So here, the first thing that I'm going to do is undo my subtraction by adding 10 to both sides. The next thing that I'm going to do is divide both sides by the number that's in front of the power. I'm doing BEDMAS backwards to get x by itself. And then the last thing that I'm going to do is raise both sides to the reciprocal power or to the inverse power, which leaves me with x on the left-hand side, and then I get 25, the square root of 25, and then cubed. This is an interesting question because the square root of 25 could be negative 5, or it could be positive 5. So this is an example of a question where I do actually have two solutions. So I've got x equals negative 125 or x equals positive 125. In example F, my subtraction is happening inside the brackets. It's part of the base of the powers. So the first thing I'm going to do is raise both sides to the inverse, which means that on the left-hand side, I'm left with x minus 3 because now my exponent is equal to 1. On the right-hand side, I have the cube root of positive 27, which is 3. 3 squared is 9. And then I'm going to add 3 to both sides, which gives me an answer of. This last example involves factoring and some consideration for our domain of our x values. So let's go ahead and start off by factoring out x to the minus 3/2. So I'm going to write that out in front. And I'm going to factor this out. I know I'm left with 1 for the first term because anything divided by itself is equal to 1. And then in my second one, I'm going to do x to the 1/2 divided by x to the minus 3/2. When I'm dividing powers, I'm going to subtract the exponents. So this is going to leave me with x squared equals 0. So now from this, it looks like I have a lot of solutions. I have x equals 0 from this part right here. I also have 1 minus x squared equals 0, or x equals plus or minus 1. Now, if I have to consider my domain, this one is particularly important, especially the fact that I have these even roots on the bottom. So let's talk about the first answer, x equals 0. This first term is actually 1 over x to the 3/2. This means that x cannot equal 0. So that means that this answer is not valid. It's not in the domain. So I would say here, x has to be or not x has to be greater than, I would say that x is not equal to 0. That's one of my restrictions. The other thing that I notice is that these bottom values of my rational exponent mean that I have to take the square root of whatever the input of x is. If I'm taking the square root, or if I'm taking an even root, my answer, my x value, has to be greater than 0. So I can actually extend this to say that my restrictions are x is greater than 0, which means that my only valid solution is x equals positive 1. If you want to check it on Desmos, you can verify that this is the only solution, is positive 1, because of the restrictions on the domain, because of my exponents, and where they are located.